Hi, and welcome to my talk, Flippin' Awesome Streaming with Open Source. I'm Tim Spann, developer advocate at StreamNative, and hopefully I'll show you some cool stuff you can do with a bunch of the main open source projects around streaming. I've been doing this for a number of years, working with different technologies like Hadoop, Flink, Pulsar, Spark, NiFi, Java, lots of different tech out there, a bunch of different companies, and now I'm with StreamNative. Today we're going to cover my main four projects I like to work with: NiFi, Flink, Spark, and Pulsar. Show you a little bit how to ingest data, show you a little bit with IoT, cover a little bit on MQTT, do a little Spark, do a little Flink, show you a little dashboard, cover what, how, and why. So first off, though, I want to show you a working application, show you different parts of it, and we could touch on them again later. If you have questions, definitely contact me. But I've got some sensors over here on a small device. Those are sending those messages to Pulsar using the standard Pulsar channel. We could have used MQTT, and I'll show you how easy that is to do with, for example, a Java application. I've got that sending over MQTT, over Kafka, over Pulsar, over AMQP Rabbit. Depends what you're comfortable with, what language you're using. One example, we're doing Python, another we're doing Java. It's up to you. And once we have it in Pulsar, besides having it safe and easy to distribute in a scalable manner, regardless of where you're running, doesn't matter if it's in Kubernetes or in Docker or on bare metal or on any of the clouds out there, very easy to run and distribute that data. And I'll show you how we could easily pull that data with Flink and with NiFi, with Spark, and we'll do some, use a sync that just came into Pulsar. We're pushing that data out to Delta Lake, and we'll examine that data in Spark, make sure it looks okay. It's very similar to Parquet, but it's a little different. So when you get these slides, I've got a built-in demo to show you one of the other features here, but we don't need to cover that. Now, all the source code out there for my demos are in these two GitHub repos. They're linked about, and we'll make sure you have them. One is my FlipPy Delta Lake Thermal. This is the example of a Python app running on a Raspberry Pi, doing some sensors. It has a thermal sensor on there, and pushing that into Pulsar. Then we're doing a couple of cool things with it. One important thing is, for this version, got to make sure we have a schema and that we don't allow nulls and we don't have any maps in there. Pretty straightforward. So we run it, we get our example back. I'm doing JSON. You could have done Avro or Protobuf. In first time you're working with something, probably easiest to do JSON, and that tends to be supported by every library you could think of. So that's kind of helpful. I set up a very simple Delta sync here just to commit it into a directory. This could be an S3. This could be anywhere. On my local machine, I'm just putting this into a regular directory. Just makes it easy to debug and test locally. Setting up the sync is easy, and we can monitor it, check the status of that. We can do that with REST or command line. We'll do command line, that's easy. And we'll take a look at all those files getting written, and then we'll query it with Spark. And we can look at the files themselves if we want to. You'd also query it with Flink SQL. Gives you an option of doing continuous SQL against the data. And we could also look at that data while it's in the topics using Presto or Pulsar SQL. And you can do all that pretty easy. The other demo I'm showing you is my air quality one. This is a Java application. This is running, collecting data from a REST endpoint and pushing that into Pulsar over a couple of different channels, which is interesting. And we could also look at that data with Flink pretty easy. So let's take a look at this data running, and we'll get that fired up. This is the first set of data. This is that air quality data. This is a standard Java application in Spring. There's a new library coming out to make this even easier with Spring, and look for that sometime around Pulsar Summit, maybe a little later. But my example is pretty straightforward. I'm sending that REST data to Pulsar topics, sometimes over MQTT, sometimes over AMQP, sometimes over Kafka, sometimes over Pulsar. When I send it over Pulsar, I get back information that said it went in. I know I have an acknowledgement there. Really nice. Not the same things available in some of the other libraries. Then I update it to ScyllaDB just to have a place to see it. Now that data is being consumed by a front end that I wrote in JavaScript that I put in this very simple single page app that we referenced in the documentation. This lets you read records from Pulsar via WebSockets. You don't have to know anything special about Pulsar. Very straightforward API to do this. And lets us get this data as it comes through. Pretty easy to consume it as it comes in. But lets us build these dashboards really easy, or maybe put that into a Jupyter Notebook, what have you. Next up, I have another source of air quality data that Apache NiFi is reading. And I'm going to run a record here just to get that going through the system. And what's nice with NiFi is I don't have to write any code. This just lets me manipulate data on the fly, doing pretty simple things like here. I'm just pulling out certain fields using JSON path, which is just a scripting, very similar to XPath, if you know that. Splitting out records, building a new record of a new style that just has the fields that I'm interested in. Pretty straightforward, but makes you be able to do things that I like. And then here I could use, thanks to the power of Apache Calcite. If you don't know that project, check it out. It's in Phoenix, it's in NiFi, it's all over the place. Powerful way to do standardized SQL anywhere, which is great. So we could use that here to look at some of the data in those records as they come through the system. And here I'm looking at PM10 air quality records and checking the value. If it's above a certain thing, I'm publishing that to my cloud system. What's nice, you'll notice in NiFi is we've got these built-in queues and with configurable back pressure. So something's not running, don't lose anything, which is great. Now, for the ones that aren't filtered, I'm just passing through everything. I'm just going to push this into my local Pulsar cluster. My friend David wrote the connector here. Really straightforward, you to be able to connect, especially if you're just have a standard cluster like me. And then you have lots of different options for your authentication. Since this is running for me inside of my local air gap system, I turned off security. Even then, probably should have it on. And I do that when I'm talking to my cloud resources, StreamNative, but just to make it easy and to show real simple demos for people doing Docker or maybe their local Minikube. Very easy to just push that data there. And you'll see even on a single node NiFi and a shared server, we're pushing through data in the thousands per try. We could even go faster if we need to. So we've got that air quality data coming through. We've seen it in the front end. What else can we do with it? Now here, I'm just keeping producing data. Now I can show you different ways to look at data here. So I could do look at the data in Flink. And what's cool, if I do it in Flink, I could do things like aggregates. I can look at data as it's coming in. So this is event at a time. So if we look up here, it just built and deployed my Spring job, my Flink job, and I can see it running. And I can start seeing that if data is coming in. And we looked, we're still producing data, so it's already coming in. And if we want to look at it more detailed, I can look into that and see the details. But this will keep adding records as new ones come into the system, and it'll keep updating those aggregates like maximum and min. This is very nice. Now, as part of this SQL, I could do an insert into another topic. So this could be the output that I'm looking for, and I could deploy this as a standalone job or write this in Java, Scala, or Python just to have a buildable app out there. I mean, you probably don't want to run your production apps from the command line client here, but it shows you what you can do very simply. And this could just go into another topic. This could be joined with other data. It's very easy to do, real-time analytics with SQL, thanks to the power of Calcite and Flink. Very cool stuff you could do there, and very straightforward. So that's one set of data. This was that air quality data I was talking about. I'm going to stop sending millions of records there just for that. So let's close out of that one. The other little demo I have is I have a sensor running on a machine here, and we can connect to that machine here. And I'm just going to start running this app. This is a Python app. It's doing native Pulsar library, and it's read from its sensors, and it's starting to push through data here. And I'm outputting a JSON result of that right here. You start seeing data coming through the system. So that's good. We have data coming through. It's about once a second. Not super fast, but fast enough. And I've got another NiFi application that's just going to act as one of the consumers here. And it's got its own subscription, and we're consuming from this topic. Lots of things we could set here if we needed to. So we've got that data coming in, and I could, again, using Calcite, route it. Here, what I wanted to do is not grab every field, just grab ones I'm interested in. The humidity is over 35%, which is actually pretty comfortable, but for our alerting sake, I wanted to do that. And I'm just going to push that to another topic. Again, I could push it to storage. I can send it to a logging system, send an email, whatever makes sense for you. I'm going to look at the data lineage here that NiFi provides, and I could see what's going on with the system, what got changed. So it pushed a result out to that topic, and I could see what that record was. As you could see, those are just those fields we picked with Calcite, built our new JSON, and now it just has these records I care about: humidity percentage, temperature in Celsius, and a CO2 reading, and a little bit of metadata there just to make it easier. And we'll see we have all that other metadata that came through the system, including a unique ID. Makes it pretty easy to track things. If things failed, here I could set it up to retry a couple of times. And then when it's dead, I could push it to a file system, or maybe push it to a dead letter queue. That's up to you what you might want to do with that. Now, we could run another Flink job for this one. Pretty straightforward to do. So if we go to Flink, and we could take a look at the different tables we have. We have one for the Pi sensors. So we could just take a couple fields maybe that we're interested in, and see what's going on here. Maybe temperature, humidity seems of interest, CO2, maybe that timestamp. And let's grab that. This is in special quotes because of that dash in there. Did I spell something wrong? Yeah, I'd be careful there. It's very easy to get a typo when you're working with a lot of different fields there. There's some more advanced tools to make reading the Flink stuff a little easier. But let's, best way is to cut and paste, right? Hard to screw that up, even though we did that once. So while that starts up, we'll see it's deployed a new job. Eventually, here we go. And this one's a little simpler because it's not doing any joining. There's no order by. This is just a straight select. So as data comes into the system, it's just going to get it. And as you can see, as a new record comes in, new one shows up here. Again, I could push this to another topic, have this read by an app and do something with it. But this is just a great way to debug what's going on in your system and see that, yeah, data is traveling through. Pretty straightforward. Something else we could do with this is, as I mentioned, we have a sync, and that sync is pushing to a directory here, and it's producing all these snappy compressed Parquet files with in the correct Delta Lake format. And those are just coming into the system. And I can also check, see how many records that I'm pushing through this sync. Again, using a sync is very easy within Pulsar. Still pushing that data out there. And we could take a look in Spark, and I could see, just some of the latest data there that's in those fields. Pretty straightforward to do that. Now, when you're connecting There's a couple of Delta libraries that you have to include when you're running your Spark, but pretty easy to do, and I have that documented. Here, we are just going to read those Delta formatted files or table from this directory. And as you can see, it quickly made it available and had all those fields available in the schema. And I could select from them, whatever fields I want to show as many of those as I want. Here, this show 25 is the number I'm showing, and 100 is how much space I want to give each column, so they don't get cut off. Again, if you're outputting this to a file or something else, not the biggest concern of yours. I mean, that's just display, but you get the idea. So I'm going to stop that one running. We showed that. We showed the Spark. We showed NiFi. That's a pretty good quick demo. We don't have too much time here, so we'll go back to the slides to kind of say what we were doing and how. Now, all these things together, I like to call this the flip stack. This is an easy way to put together the terminology. We could call it the flip pattern. And it's really a couple of projects that work together really nice. And I've got an article on that at StreamNative. But Pulsar, that's my main project. And it's kind of the glue because I want to get the data, make it available to as many people who want to consume it, whether they're a Flink job, a NiFi job, Spark, Java, Python, Go, whatever you may have there. And often I like to store this data in some kind of permanent data store. Lots of good ones out there like Scylla and Trino and others. So streaming, we want to do this in real time, which is, as fast as possible within reason, which, as events occur, I want to process it. So that could be millions of records to you. That could be thousands, could be billions, whatever makes sense for you. Processes that as the events come in. I don't want to wait for 1,000 of them to come in. That makes kind of more sense when I'm pushing that to the Delta Lake. But as I'm getting that data and I want to process it in Flink, I want to get each event as it happens. I could join different streams of data with SQL, which is nice. I want to be able to find and do alerts as soon as they happen. Bad data comes in, there's fraud, there's a fault. Let me know right away. I want to be able to ordering them. I want to know when things arrive. If this come in, what if data comes out of order? That may be important. Something might be wrong with the system, or you might have a lot of different devices out there and they're not reporting properly. We're working on this continuous stream of data and never stops. Why do we like NiFi? I showed you some of those reasons out there, being able to drag and drop, move things around, lots of sources, lots of syncs. You'd also write your own custom JVM apps, typically in Java. What's nice is very easy to scale this out. Support for full lineage. Great open source project's been out for a long time. Very stable. Flink. This one's a lot of fun, being able to do that continuous SQL real easy. Scales out massively. Also does support for batch. I mean, you do need to do some batch stuff, especially storing maybe massive amounts of data you're moving around. The connector for Pulsar is native and is available from the Flink project, and it's really fast. It's a great place to do your event processing, whether you do it in SQL or you write it in Java, Scala, or Python. Spark, you haven't heard about Spark and you're at ApacheCon, I'd be surprised. But it's great for ETL, great for machine learning, support for those big three languages again, very scalable, very easy to stream data to and from Pulsar, again, that native connector there. And now with some different lake houses available, this gives you some power to do some pretty cool stuff, regardless of how much data that is. Pulsar, again, my favorite here. One place to do any type of messaging, any type of streaming. And we saw in the demo, support for multiple protocols. So you don't have to go, well, I have all these legacy apps, so I have to rewrite them. No, you don't. I could use that Rabbit protocol. I could use MQTT. I could use Kafka, use Pulsar, use Rocket. One place to do all that messaging. Really nice. Compute and storage are separate. Makes it easy to scale out. Makes it perfect for Kubernetes. Scalable as you need to be. Billions, trillions, petabytes of data, whatever it happens to be. This is a subtle feature that people don't think about always until you need it. Multi-tenant. I can have a lot of different apps, companies, projects, all on one cluster and with different protocols. This makes it very easy for you to have, you know, a simpler infrastructure. So I'm not running hundreds of little clusters for every little group, and with full security and full performance and all those features you expect in a modern cloud system where I could scale it up, scale it down, scale it however you need to, without sacrificing the ability for multiple people to use it, without having to put in special hacks to make that work. Again, multi protocol support, different style of messaging, not to overlook that. ActiveMQ, RabbitMQ, those support some complex messaging styles, work queues. Maybe you have messages come in, you don't care about order, I want them processed by as many people who can consume them. Message queuing supports that, and we could do that in Pulsar. You're used to things in Kafka. I have a log, I've got CDC, events come in order. I want to process the events as they happen. I care about ordering, I care about performance. Pulsar supports that as well. We saw NiFi as a way to ingest, makes it pretty easy to get that data in. And as I always recommend, first thing you do, once you have that data, get that into Pulsar so you know it's safe and secure. It can be distributed, geo-replicated any way you need it, and be consumed by as many applications out there as may need to process it through that next step. Ingest, I could also easily do with a standard application, push that out to Pulsar, whether you're in Java, Go, Kotlin, Scala, C#, C++, tons of different language support for Pulsar, and you could use the native Pulsar libraries, or you could use libraries for some of those other protocols. Also, a nice feature of Pulsar is being able to use it to ingest data without writing code. You write a little bit of configuration that probably has a login, maybe passwords, that kind of stuff. Points to where your data is. Maybe your data is in Kafka. Maybe it's in Google Cloud, PubSub. Maybe it's in a file system in a database. Easy to configure those to stream that data right to Pulsar. And then you could use it for whatever apps you may have. And on the other end, while that data is coming in, I could send a copy of that, sync that into a data store. So one secret in Pulsar, besides having a really cool way of doing storage, got built-in tiered storage. So if you want to have that data automatically go out to S3 storage or somewhere else, I can configure that in Pulsar, and it's still available in the system. So if I want to go back to the first message that ever came in, I can reach that even if it's in that S3 storage. I don't have to know it's somewhere else. The libraries and the system take care of that for me, which is really nice. We showed an example of sensors coming in. We also have other ones. I have one for reading different temperature sensors that I have outside in the garden, know what's going on. Things like pressure and humidity, those sort of things. Very easy to read that within Pulsar SQL, and we've got the links to that code for you. MQTT library and used in Pulsar. People will tell me, is this a proxy or some kind of bolt-on or something that kind of sort of hacks it together? No. If you look at this diagram, it explains to you how important all these protocols are. It is implemented no different than the native Pulsar one. So it doesn't matter how you get data into or out of Pulsar, it's treating that with full support there. So you can use it as a regular MQTT broker, as a regular Pulsar broker. What's cool is data coming in, maybe I come in MQTT because I'm coming from IoT devices. I don't have to have that data come out the same protocol. So I could have someone pushing in MQTT, goes into a topic. Once it's in a topic, it's Pulsar. I could pull it out with any of the Pulsar libraries, or I could pull it out with MQTT or Kafka or Rabbit or WebSockets, or have Flink do it, have Spark do it, have NiFi do it with Pulsar SQL. Very easy there. We support the regular MQTT libraries. I just point, this code is work with any MQTT broker. It works with Pulsar. just as a small example of pushing data into Pulsar. Looks just like regular code. If you look at the source code for air quality, I'm doing that with Java as well, just to show you that flexibility. A new feature that I showed in the demo is a sync for Delta Lake. There's also syncs for Hootie and Iceberg. What's nice here is do a little configuration, and now I'm pushing as much data as I want into these modern Lakehouse cloud data warehouse formats. Makes it great for doing your analytics without having any heavy lifting here. Don't have to worry about having dual ingest or something. Get your data into Pulsar. We'll figure it out the rest for you. Very easy. And then Spark, we have a great connector there to do our Spark SQL. And we could just read regular topics. But again, I was showing you in the demo using Spark to read those Delta Lake tables that we built. But again, there's some really good connectors out there to go right from Spark to Pulsar, so you don't have to wait till you hit a data store, or you could do both. Depends on how you want to ingest data, how many copies you may want. Are there variants of the data? Are you joining data together, transforming it, cleaning it up? Whatever makes sense for you. Many options with Spark. Flink SQL is kind of one of my favorite projects. That's why I put it in that part of the flip stack. That's the F. Just being able to do simple, powerful queries without heavy lifting. I create a catalog for Pulsar, really easy. And then I get all my topics available. Again, define a schema for any data you use. I recommend JSON or Avro. Protobuf's a little bit of a wild card there. Do your selects, do your order by, maybe do an insert. Lots of power you could do here, and you can connect with other catalogs. So you have a Pulsar catalog, a Kafka catalog, one for HBase, one for Scylla. Anything Flink has a catalog for, and join those together. Pretty powerful. WebSockets are surprisingly easy with Pulsar. And in my example application, I call to Pulsar via WebSockets to get data back. I subscribe and I get data as it comes in. But I can also push new data to Pulsar over WebSockets. So I could have a form on my screen, press a button, send it over. I do that for a chat app. It's a simple application, but you get the idea. If you want to enter data into the system, very easy. You could also do that for, say, web analytics. You know, maybe I have things on the screen that are providing updates, send them right to my scalable messaging system. Very easy to do that. The code is very straightforward. It's standard WebSockets. I was doing jQuery. You could use any of the modern JavaScript libraries or pure basic JavaScript. Very easy to do. Not much heavy lifting here to get that data back. Parsing it's pretty easy. One thing is it comes in binary, so you got to convert it and parse that into JSON, but that's all the code right there. Connecting to Pulsar from Spark, also pretty easy. Again, we remember you saw that Delta format. This is the Pulsar format. We put in our service URL to connect to our broker, plus the admin URL. That's how it gets web services information. And then we put our topic name in, load, we're ready to go. And it doesn't matter which of these devices that I might be using here. Pretty easy. So we got messages, we've got events, we've got a streams. Very easy to use them for what you need to do. I think the first thing you have to think about is, what is my data? What does it look like? I need to know things like field names, types, is it nullable? Set up a schema, build a topic, start getting some data in the system, then figure out, what do I need to do with it? How do I want to analyze it? What makes the most sense? Once you have it in Pulsar, it's very easy to do those next steps of put it in a table, make it available real time, you know, write an app in Spark, write an app in Flink, get that data in, get it out, do with what you need to do. Links to lots of other examples out there, whether you're working with things like ClickHouse or MQTT, lots of different example codes out there. Every week, I put together a newsletter in LinkedIn. very easy to subscribe. Once a week, you'll get my newsletter has articles, it has the new releases on the projects, example videos, articles, cool tools and projects I saw, good examples, usually around different Apache projects, Flink, Pulsar, NiFi, Spark, Java, and different open source things out there, maybe events happening, where I'm going to be. If you need to contact me, see me at the upcoming events. I'll be at Pulsar Summit, San Francisco, bunch of other events happening around the country. ApacheCon in New Orleans this year. Hopefully I'll see you there, or you'll see the videos. Lots of different resources, learning Pulsar, a couple of my articles, all the example code out there, how to use Pulsar as if it was Kafka. All my GitHub and contact information is here. Please feel free to reach out. It's the best part of open source is, working with other people, getting things done. Yeah, if you see any typos, you see things you want, do a pull request, put an issue out there. The Pulsar community and most of Apache and open source loves that input, loves that feedback. We love forks, we love stars. So definitely check it out. Give it a try. If you get stuck somewhere, please reach out, put an issue out there. Sometimes things work very well in your particular container or your system, or maybe you need a certain amount of RAM. Definitely reach out, and thanks for coming to my talk. Hopefully you liked my pictures of cats. Hopefully you liked the demo. If you need anything else, feel free to reach out. And thanks again for coming to my talk. Today's talk was flipping awesome streaming with open source, covering Flink, Pulsar, NiFi, Spark, Delta Lake, and some friends. So thanks again, and hopefully I'll see you at the next event.